Let's take a look at this one. This one's kind of, oh, this one's very ugly. Man, the instructions said to factor and simplify, right? So I think that means break it apart by factoring and then put it back together in a way that's nice and pretty. It's kind of ambiguous. It depends on the context, and these problems are kind of written just to make you exercise what you know about exponents and reducing and common factors and all that kind of thing. So I'm not going to get too hung up on that. But first thing I'd suggest is, like when I did this problem a couple times, and I mess up when I have something like this because I keep rewriting it. So and I can rewrite it wrong. So what I'm going to do is I'm just going to say I'm going to rewrite it and I'm going to let just the letter A be that base. So here, let me show you what I mean. If that doesn't make any sense yet. So what I did is I took the base 5 plus x and I replaced it with a. And that way when I'm doing all my work, the bases are the same. I'm not going to change the base in any way. And then in the end, when I'm done factoring, then I'm going to put the base back as x plus 5, and then maybe I can do some simplifying. So this is just something I do to help me keep out of trouble a little bit, right? I did this problem two different ways. I'm not sure which one's easiest or which one's best. Get the same answer either way. One was cleaner. Mm, so I don't know. Let's go with the easier one. Let's go with the one that was a little bit cleaner. And what I did to do that is I separated this. I made this into two separate fractions. So like 3a to the 1/3. The reason I did this is just because it helped me to reduce this part and reduce that part. The other option, if you don't want to do it this way, is instead of doing that, you can actually factor out the numerator and then reduce and then put it all back together. But this is still true. Just like if you had 5 minus 10 over 15, that's the same as 5 minus 15 minus 10 over 15. Those are the same. You can go either way, right? So what I did is I took something like this and I separated it. See, that's all. Now I'm gonna simplify these. A couple things. First of all, these bases are the same, um, and that means you end up subtracting. But actually, it's actually just reducing. Like imagine you had this. How many more x's are in the numerator? Or sorry, in the denominator? There's two more, right? If you have 5 on the top and 2 on the bottom, or 7 on the bottom, 5 on the top, 7 on the bottom, then that means there's two extras in the denominator. So here I have 1 and 2. It's a third, right? But 1/3 and 2/3. That means there's an extra 1/3 in the denominator. So this one's going to reduce to just this. See? 1/3 and 2/3. Now, if you wrote out like the steps, which I would never do, because I think this is actually very confusing. This would be negative 1/3. And then, of course, a negative fraction, sorry, a negative exponent means division, because exponents are repeated multiplication. Negative means opposite. The opposite of repeated multiplication is repeated division. And the way we divide is we multiply by the reciprocal. So that's why this becomes that. So I prefer using this kind of logic to get from here to here. Either way. All right, now we're going to do the same thing on this one. We're going to be using what we did here with division to simplify this. So look, when I have x to the, or a to the negative 2/3, that means I have to do the reciprocal. So I have 2/3 that's going to go down here. I'm going to have 4/3. Because I already have 2/3 down there. 2/3 plus 2/3 is, sorry, 4/3. That's a 4. 4/3. So here's the way that would look. That would become, this one's still there. That's right there, right? This one's going to go to the denominator. And there you go. 4/3 and 4/3 makes, sorry, 2/3 and 2/3 makes 4/3. So now we have this. Now what we need to do is we need to get a common denominator again and put these back together. So I need to multiply something by this fraction so that this denominator is 4/3. Because the lowest common multiple of 1/3 and 4/3 is 4/3. This can divide into that. So here's what we've got. We've got a denominator. We're going to make that denominator 4/3. We got x right there. If I multiply by a over a times a to the 1/3 is 4/3. See, it's a to the 1 times a to the 1/3. Well, 1 plus 1/3, well, that's 4/3. 1 and 1/3. Right, that's the same as 4 over 3. So plugging that back in, that would be 3. 5 plus x minus x over 5 plus x to the 4/3 power. Now, I am not sure what they want you to do with the denominator. The numerator, we could simplify. We could say that's going to be 15 plus 2x over 5 plus x to the 4/3. 15 is right there. That part's easy, right? 3x minus 1x is 2x. We have 3x here. Minus 1 is 2. So I'm not sure if they want you to do anything further with this or not. Not really sure, but that's what I got. I'm confident that's correct because I got the same answer in a couple of different ways. But yeah, there we go. Might as well show you the other way, because if you're not confused now, maybe you will be. That was a joke. I'm going to start off with using a again, okay? That's a 3. Okay. Now, on this one, what I'm going to do is I'm not going to separate it. What I'm going to do, I'm actually going to factor out something from the numerator. So check this out. I can take out an a to the 1/3 out of both of these. I can. And so let's see, watch. A to the 1/3. Earlier when I did this, I actually messed this part up. So check this out. I need an exponent right here. So hold on, don't go anywhere yet. When I distribute this, if I were to distribute back this, a to the 1/3 times 3 would give me that. That's okay, right? But a to the 1/3 times a to the what is a to the negative 2/3. So like, check this out. Yeah? So the thing that I messed up here is that these two things are going to be adding. So 1/3 plus what number is negative 2/3? Wouldn't that just be a 1/3 minus 1? Do you see? You see how I got that negative 1? So that's correct right there. Now, these can be reduced now. Just like if you had, say, 5 times x plus 3 over 15. Those can be reduced. These can be reduced. Let's do that as scratch work over here. If I have 1 on the bottom, or sorry, 1 on the top, 2 on the bottom, that means I have 1 extra on the bottom, right? So, or you could subtract them just like we did a minute ago. That's going to be a to the 1/3. And then that one reduced, so 3 minus x, a to the negative 1. Now, that is actually the same exact value, but it's just kind of ugly, right? So, not sure which answer they want. Let's go ahead and do this right there, though. X, let's see, was 5 minus x or 5 plus x? Which one was it? 5 plus x. I would actually suggest they don't want this because of that negative exponent right there. They'd probably want you to get rid of that. In which case you'd have to separate the two. I guess we could do that again. So like, we're gonna end up in the same spot. Watch. Oh, I forgot the x right here. I'm sorry. There we go. Okay, so now I have to flip that part over, just this part right here, because it's got the negative exponent, right? So this part's going to stay the same. See, I did it. I don't know why they put the x second. I hate that. And so, did it again. There we go. Same thing, you see? Yeah, we'd have to get a common denominator, you see, and we'd be right back where we were. So to make this a common denominator, do you see how you'd have to multiply by 5 plus x over 5 plus x? And you ended up with 15 plus 3x minus x over that makes 4/3. Same exact thing either way. I actually think the first way is probably a little cleaner. I really don't know what the whoever the teacher is. I don't know what they're expecting you to do with this part, but anyway, that's it. Hope it was helpful. It was a really ugly problem. I think the trick was actually just making sure that you're following the rules for exponents when you're adding the exponents, when you're multiplying, how to reduce, all that kind of stuff. Good luck. Let me know how I can help you. If you have questions on this, which highly likely, let me know.